self-organizing map is basically consists of a lattice with so many points. You see here, this is a lattice, and each of these dots are points in this lattice. The idea is, in the self-organizing map, you just give one input. You don't give several inputs like you did in your feed-forward neural network. You just give one input and train this lattice like anything for this given input. So this is a neural network that fits our requirement, because we cannot give all the bad samples, because a fingerprint that we are looking at can have so many bad samples, and we can't find all of them and train a network. So SOM fits our requirement, and my self-organizing map that I have created is based on the coherence model, basically. And if you look at this fellow, this is the input. So let's say I've taken a input which is 80 by 80 image, right? What we do basically is we break this image, the 80 by 80 image, into several feature maps or several feature squares, basically. Each square, let's say, is of size 30 by 30. So, and each of the square is consecutively broken. So along the width of this image, you could have 51 feature maps. Same applies to the height of the image, right? It's simple mathematics. 30. The next consecutive is the next thing. So to compute number of feature maps that can be consecutive along the width, you just subtract 30 from 80 and add 1. So what you get is 51. Same is the case for the height. So the concept here is simple. You have a feature map, and you will have a point in the lattice corresponding to that feature map. As simple as that. So the next consecutive feature map here will have a consecutive point here, and so on and so forth. So this lattice has so many points, and each point corresponds to a feature map on the input image, which is a fingerprint. Now let's go into each of the points in the lattice. Now this is the point in the lattice, right? And this point in the lattice will have weights, and these weights again are in a 30 by 30 array, two-dimensional array, which these weights in this of this point are corresponding to the feature map, right? So the idea is this feature map is used to train this point whose weights are these. Similarly, the next consecutive feature map will be associated with this point, and which will have its own set of weights, which will be again a 30 by 30 array. So that's the idea. So before going deep into this, we'll have to talk about two key concepts about the self-organizing map, and they are: the degrees of freedom and the Euclidean distance, which plays a major role in the self-organizing map, right? So the degrees of freedom, it's basically the number of degrees of freedom for a point in a two-dimensional space is 2, being x and y. So if we have a three-dimensional space, right, from here, the degrees of freedom for a point in a three-dimensional space is going to be 3, and so on and so forth. What is the Euclidean distance? Well, if we have 2 points in a two-dimensional space, the Euclidean distance is computed using this formula. Well, it's basically, we look at the values of the degrees of freedom of the point and we subtract the values of the degrees of freedom and square them and then take a root of them, which is a function of basically the basically the absolute value of the difference of the degrees of freedom of the points. So here it is, the Euclidean distance is basically a function of x1 minus x2 absolute value plus y1 minus y2 absolute value. So I guess you are clear with this. Let me take some more time on this. So, right, so I don't, this is a simple thing to understand, so I'll just leave it like this. So our self-organizing map, if you look at it, now this point here, right, it has got 30 into 30 degrees of freedom, which is 900 degrees of freedom. So we are talking about a big number here. It's hard to imagine a point in such a complicated space. It's got 900 degrees of freedom, but that's how it is. So the self-organizing map, or the SOM, that I have designed for the fingerprint recognition is like this. So each point in this lattice has got 900 degrees of freedom, and the value of each degree of freedom is stored in here as a two-dimensional array. Each of the weight constitutes those values. Right, so that's pretty much about it. And how do you train this? Well, for the feed forward neural network, we did it through the back propagation algorithm. We took the error and we propagated it to the weights and changed the weights so that the output is corrected. For this fellow, the self-organizing map, the idea is each point, say this point here, takes the input, is supposed to learn or train itself to this square. The next subsequent point here is supposed to learn or train itself to the next subsequent square, and so on and so forth. And and the input to this lattice, right, to this lattice, we will only give a feature map which is 30 by 30, and all the points in this lattice will compete with each other to be closest, as close as possible. The idea is whoever is the closest point for the given input, the feature matrix, feature map, will be considered the winner, right? No big deal. It is basically, we give this feature map, or we give this input, the 30 by 30, and